Galileo, and the Leaning Tower of Pisa experiment. In the 4th century BCE, a philosopher named Aristotle proposed a theory which stated that objects fall at a speed relative to their mass. Aristotle proposed that heavier objects would fall faster than lighter ones, and that an object that weighed twice as much would fall twice as fast. According to Aristotle's theory, if a 10-pound ball and a 1-pound ball were dropped from the same height, the 10-pound ball would hit the ground 10 times faster than the other. Aristotle's theory went unquestioned for over 1,000 years until 1586, when a philosopher by the name of Galileo performed his famous Leaning Tower of Pisa experiment. In his experiment, Galileo climbed the Leaning Tower of Pisa with 2 balls of different masses, but with similar shape and density. Many people of the time believed that the ball with more mass would reach the ground sooner because of its increased weight, in accordance with Aristotle's previous theory. Determined to disprove this idea, Galileo released both of these balls from the same height, and they both hit the ground at the same time, proving that time of descent was independent of mass. Many of the misconceptions of the time were caused because of air resistance, as lighter objects experienced a higher friction, which slows them as they fall. At the time the experiment took place, he had not finalized his law of free fall, but he had previously stated that he predicted that bodies of the same material falling through the same medium would fall at the same speed. This discovery influenced many scientists throughout the ages, one being Isaac Newton. Galileo's discovery inspired Isaac Newton to further explore this concept, and later discover the law of universal gravitation, as well as mathematical principles behind gravity. Newton's law of universal gravitation states that all objects in the universe are attracted to another, and will accelerate at the same rate when affected by the same gravitational force. Newton also determined a mathematical relationship between the two objects affected by gravity, which can be seen in the equation force of gravity equals gravitational constant times mass of object 1 times mass of object 2 divided by distance squared. Today, Galileo's theory stands true and has been recreated many times, and even during Apollo 15 with the astronaut David Scott on the moon when he dropped a hammer and a feather. These modern tests, while all performed in a vacuum, still prove Galileo's theory correct, as when no air resistance is present, any object will fall at the same speed as the other. With this new discovery and new way of thinking, science would forever be changed and would continue to evolve into what it is.